Hi, I'm Bill Hitchcock, and we're doing some more number conversions. We're up to part 4, and now what we're going to be doing is kind of switching things around. Rather than going from some other base to decimal, we're going to take a decimal number and convert back to a different base. And the secret is you divide by that base. So say for instance that I've got a number like 18, and it's a decimal number, so a base 10 number. And I want to convert this to a binary number. So the secret is you take that number and divide it by 2. So I'll take 18, divide it by 2. 2 goes into 18 9 times. 9 times 8 9 times 2 is 18. 18 minus 18 gives you 0. So you take this 0, this remainder, and that becomes your rightmost digit. So now that I've got that, we start over again. So I'm going to take this 9 that that we computed, and I'll take 9 and divide that by 2. 2 goes into 9, well, it goes in 4.5 times, but it goes in evenly 4 times. 4 times 2 is 8. 9 minus 8 gives me 1, so I've got a remainder of 1. So I take this remainder 1, and it becomes the next digit. All right, now I'm going to put this over here just to help on the space that I have on my pad of paper. So next what I do is I take the number 4. Take 4 divided by 2. 2 goes into 4 evenly, 2 times evenly. 2 times 2 is 4. 4 minus 4 gives me 0. That's my next digit. Then I take this 2. This one up here. Bring that down. 2 goes into 2 once. That's 2. I get a remainder of 0. That's my next digit. I still have something left, so I'm going to take 1 divided by 2. 2 can't go into 1, so it goes in 0 times. 0 times 2 is 0. 1 minus 0 gives a remainder of 1, and I've put my last 1 up there. Now, once you get to 0, you stop. Because if you don't, here's what happens. I'll take 0. 2 goes into 0 0 times. 0 times 2 is 0. 0 minus 0 is 0. And I just start getting a whole bunch of leading zeros out here, which, just like if I ask you, how old are you? And you tell me that you're 19 years old, well, you could also say that you're 0019 years old. You could say that I'm 000019 years old. They're all the quantity 19. So hence, I don't need those leading zeros. So that's why when you get to 0 at the top, we stop. So let's try another one. Let's take a number like, how about 35? And it's a decimal number. I want to convert this into a binary number, so we divide by 2. 35 divided by 2. 2 goes into 3 once. That's 2. That's 1. I bring down the 5. 2 goes into 15 7 times. That's 14. I have a remainder of 1. Or you could have, I suppose, just said 2 goes into 35 17 times. Right? I take this remainder. It's my rightmost digit. We'll take 17. Let me move this up a little bit. We take 17. Divide that by 2. 2 goes into 17 8 times. 8 times 2 is 16. I get a remainder of 1. It's my next digit. We'll take the 8. I'm just going to write it up here. 2 goes into 8 4 times. 4 times 2 is 8. I have a remainder of 0. There's my next digit. Take the 4. 2 goes into 4 twice. That's 4. I get 0 for the remainder. I take 2. This 2. 2 into 2 goes once. 1 times 2 is 2. I get a remainder of 0, so I've got another 0 here. And finally I take 1 divide that by 2, goes in 0 times. That's 0. I get a remainder of 1. I put my 1 up here, and I got 0 on top, and we stop. And there's your answer. And if you want to check them, do what we did in the past. We said that this is 2 to the 0, this is 2 to the first, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth. That's the 1s, the 2s, the 4s, the 8s, the 16s, the 32s. I've got 1 times 32 is 32 plus 0 times 16 is 0. 0 times 8 is 0. 0 times 4 is 0. 1 times 2 is 2. 1 times 1 is 1. 32 plus 2 is 34. Plus 1, sure enough, I got 35, just what we started out with in the first place here, and our numbers are checking. So that's a good way to kind of check your math, find out if it works, give these a try, and we'll see what happens next time.